All right. Hello, CP Mathers. We, as you can tell, I'm not here today, but I want to go over some problems from last night's assignment, just to review quick, and then go over some practice problems for today that will help you do your assignment. So this is number 26 on page 31. It's like the ones we did last night. So I'm going to show you how to do this one. So we have, take care of the coefficients first, which would be the 5 and the 10. And I know that 5 goes into 5 once, and 5 goes into 10 twice. Then I look at the variables. I see that I have a b to the 4th in the numerator and a b to the 8th in the denominator. And so we go and put the b where the higher exponent is, where the 8 is. So the b is in the bottom, and then just subtract 8 minus 4. So I get b to the 4th. We don't want any negative exponents in our answers when we do these types of problems. So I have a w to the negative 3rd power in the numerator. To make it a positive exponent, I'm going to move the w down to the denominator and make the 3 positive. And we've got it simplified. So that's a type of problem we did yesterday, one of the types. And it's very similar to some that we're going to do today. We'll throw some fractions at you with the exponents. The bottom here is a scientific notation problem. I just want you to write it in normal form, which would be decimal form, I guess, is what we call it. And anyway, that is 6.14 times 10 to the negative 8. So I want to write it in its proper form, so I put my decimal point, and I'm going to move it to the left 8 places. That's going to put 7 zeros in front. So there's 1, 2, 3, 4, 5, 6, 7, and then the 6, 1, 4. So just a quick review of what we were going over yesterday. And those types of problems you should be able to handle. So today we're going to do a little bit of the same type of stuff, throwing some fractions at you. And we're going to simplify some radicals, do some FOILing, some add, subtract, some radicals to rationalize some denominators. So again, more review, but I wanted to show you how to do these quick before you do your assignment. So this first one, we want to just multiply the two monomials, and we'll just multiply the 4 times 2, the coefficients, and get 8. And then just like yesterday, we're going to add the exponents for the variables, which are the bases. So we've got a and b. We're going to add the 2/3 and the 1/3 for a, which is 3/3. And for the b, we're going to go 1/2 plus 3/2, which is 4/2. And that way, we could simplify 3/3 would be 1. So you can put the 1, you don't have to. And then 4/2 is 4 divided by 2. So that would be 2. So it's the same rules as yesterday, our properties of exponents, and we just add our exponents, multiply our coefficients. This next one's a division problem. Same rules as yesterday. So we're going to see what goes into 9 and 3, which would be 3. So 9 divided by 3 would be 3 for that coefficient in the numerator, and 3 divided by 3 would be 1. You don't have to put the 1, but I'll go ahead and put the 1. And then what we did yesterday was we looked at the higher exponent. 3/4 is higher than 1/4. So the a's would stay in the top, and we subtract 3/4 minus 1/4 would be 2/4. And for the b's, the 2 is bigger than the 1 exponent-wise, so the b will be at the bottom, and 2 minus 1 is 1. And you don't have to write that 1, but you can. Now, since you can reduce 2/4, we should make it a to the 1/2 power, and then over b is what we would have. So again, you have a few problems like that where you're going to have fractional exponents, but the rules we talked about yesterday will still apply to those problems. All right, here we have a cube root. Okay, so we want to simplify this, and the way we simplify radicals is look for, sorry about that, look for groups of 3 because it's cube root. Okay, so we're going to do a factor tree for the 16, and we'll do factor trees for the variables. So with 16, oops, let's undo that and get back to my pen. All right, so for 16, we could go 4 times 4, and then 2 times 2 for both. If it was square root, we would know it would just be the square root of 16, 4, but since it's cube root, we're looking for a group of 3 of the same number, which we have 3 2's there. So that means I can pull a 2 out front this radical, okay? If I do a factor tree for the A's, I would just write, so there's a group of 3 A's. So that means I can pull an A out front. All right, for the Y's, I can do groups of 3 for Y's like that. There's 3, there's 6, and then 1 left over. So I have 2 sets of 3 groups of Y. So that means I can pull out 2 Y's, or Y times Y, Y squared. Okay, so if you look, I have a 2 left over and a Y left over. Okay, so when I finish this up, remember it's cube root, so I do my cube root symbol. It was supposed to be blue, but it wasn't, that's okay. And then remember, we have a 2 left over and a Y, that stays underneath the radical sign, we call it the radicand. So that would be the cube root of 16, A to the 3rd, Y to the 7th. When I simplify it, is the answer I just finished up. So again, look at your index. That's what that cube is at 3 inside the radical there, or outside, I guess. I'll circle it for you. At 3, we call the index. When the index is 3, we're looking for groups of 3. If the index is 4, we'd be looking for the groups of 4. And when we have a group of 3, 4, whatever it is, we pull it out front and we multiply. Whatever's left underneath, we multiply together as well. So we have a few problems like that for your assignment tonight. Okay, here we're supposed to add these 2 radicals, so we have to simplify them first before we can add them. We've got to have like radicals. So this one has a 4 for the index, as you can see. I'll circle that as well in purple here. That's our index. So I'm looking for groups of 4. Okay, so when I do a factor tree, I think I'll do 12 times 4. And then 3 times 4. And 2 times 2. And 2 times 2. So if you look, I've got a group of 4 2's. So that 2, there's 4 of them, I can pull out and multiply it. So I get negative 16 out front. And it's the 4th root, don't forget that. And there's a 3 left over. So that 3 will go underneath. Okay, so the negative 16 came because there was a negative 8 in the beginning out front. And then I multiplied by the 2 that I could pull out because there was 4 2's. And then for the 243, that is 3 times 81, which is 9 times 9, and 3 times 3. So again, I'm looking for a group of 4 of something. So I can pull the 3 out. But as you can see, there's a 2 there. So I'm going to go 2 times the 3. So that's a 6. 4th group. And then if you look again, a 3 is left over. So 3 is left over there. So now if we look at the problem, we've simplified both those radicals, and we have a negative 16 4th root of 3 plus 6 4th root of 3. Now I have like radicals. I can add those. So negative 16 plus 6 will be negative 10. And then it just stays 4th root of 3. Okay, so you have a few problems where you're going to have to simplify by adding or subtracting. Must have like radicals. The next time here, the next one, I have to multiply these two quantities, two binomials, we'll call them, and we got radicals in there. So we're going to have to, let's get rid of that shade. Standard page, move that down. All right, so remember, when you have this type of problem, okay, it's multiplication. There's no symbol between the two parentheses. So we're going to FOIL it. First, outside, inside, last. So first, square root of 5 times the square root of 5 is the square root of 25. Outside, square root of 5 times 4, we just usually put the number in front of the radical, so 4 radical 5. Inside would be 3 radical 5. And then last, 3 times 4. Now remember, over here, this square root of 25 is 5. All right, so like terms, we got 5 plus 12, 17, and 4 radical 5 and 3 radical 5 are like radicals, so that's 7 radical 5. Okay, so FOIL first, simplify radicals, and then combine like radicals and like terms. And then the last type of problem is you're going to simplify a radical. If this is a regular square root, okay, and if you remember from last year, we are not allowed to have a radical in the denominator. So think about this problem like this. Okay? We can't simplify this radical, this fraction, because they don't have any common number. But if they did have a common number, like let's say it was 3 over 18, we would reduce it to 1 over 6 and then do the problem. But in this case, we can't simplify it. So I like to rewrite it as separate radicals and then rationalize the denominator is what we're doing. That means we're going to take that denominator and get rid of that radical sign. So we're going to multiply the top and the bottom, the numerator and the denominator, by that radical 18. And it's, remember, something divided by itself, something over itself. Radical 18 over radical 18 is 1. So it's just like multiplying by 1. So when I do that, I just do 5 times 18, which I believe is 90. So that's the square root of 90. And then radical 18 times radical 18 is 18. Now a lot of kids will stop there, but we have to make sure we simplify. And the radical 90 can be simplified. So I'm going to do a little factor tree. That's 9 times 10. Again, it's square root. So when I do square root ones like this, I just look for perfect squares and I circle them. So I know the square root of 9 is 3. So the 3 will come out front. And then 10 will just be 2 times 5. So there's nothing I can pull out of there over 18. Because the square root of 18 times the square root of 18 equals 18. That's where that came from. But I'm still not done because now I have a 3/18 here, which if you remember I said, what if it was 3/18, I'd reduce it to 1/6. So it's 1 3 divided by 3, and 6, 18 divided by 3. So there's our final answer when we rationalize the denominator. So those are the types of problems you're going to have for your assignment tonight for homework. Here's your assignment. Let's work on it in class. Don't give Miss Bird a hard time. And thank her for helping you, because she will help you if you need help. So I will see you tomorrow on Wednesday. And we'll have the practice quiz tomorrow after we go over this homework assignment that you can work on in class. And then we'll go over the practice quiz on Thursday. And then we'll have our first quiz on Friday. So if you have any questions, you can email me. I should be able to answer some emails later in the day and help you out if you need it. So you guys have a great day, and I will see you tomorrow.